Innovation. Okay, I'm gonna have to look through my phone to be able to edit these. So, all right, are we recording? We are. Okay, what is up, YouTube? Half an hour later. So this is another tutorial on GPIO. So you guys have probably already worked with GPIOs. That's how we turn on the LEDs and turn them off and all that kinds of stuff. So they're super useful. Usually we just use them to like debug, like what's it called? Toggle debug LEDs and also toggle switches that connect to our main relays. So that's pretty useful stuff. So GPIO stands for General Purpose I/O. There's some more formal definition, so you can just like click here. It's like a Wikipedia link on what a general purpose input-output is. But basically, the gist of it is that it's basically a pin on an integrated circuit. So in our case, our STM32. That's behavior is and whether it acts as input or output is controllable by the user at runtime. So it's like even when you're running your program, you can like change the status of your GPIO and change it to like input or output and all that kinds of stuff. So that's GPIO. Let's go down. So STM32s have many pins. I think the family that we are using has like something about 47 pins. So I showed them in the last video. Most of them are GPIO. Some have more capabilities, so I2C, SPI, UART, CAN, and all that kinds of stuff. So in the case that you're using it as one of these guys, you would have to configure the GPIO to have like not be a strictly GPIO pin. You're using it as a I2C pin, and usually our libraries do that for you. So you can see them on the controller board's schematic. So I've already shown this in the last video. So GPIO.h. This is the library that we have. So our library for GPIO is GPIO.h. Like you can basically see it. Let's just take a look at it here. Let's make this a little bit bigger. So if I just search through my files, GPIO.h, you can see it. It's in libraries, Midnight Sun Common, and then inc GPIO.h. So over here you can see all the definitions that we have. So GPIO address, port and pin. You can have directions, like if it's input, if it's output. The states also are kind of defined as an enumeration. So all of your code must actually have defines like this. So you should never use magic numbers or strings. And then GPIO resistor, so the internal pull-up or pull-down resistor. So I'm going to go over this as well. These are like alt functions. So this is used when you need to for example, use a pin as UART and not specifically GPIO. So that's basically that's basically how it gets used. And there's a settings object that contains all of these stuff. So whenever you're initializing GPIO, you initialize a pin you usually pass in the address of that pin, and then you pass in a pointer to a settings object, and that settings object is this. And then you can set the states. So high or low, you can toggle the state. So if it's high, it sets it to low. If it's low, it sets it to high. And then you can get the state in the case that you just want to, like for example, read an input from a GPIO pin. And usually when you set the state to high, the GPIO voltage, like the actual voltage, goes to like 3.3. If you set it to low, it just gets grounded. So that's GPIO. That's our library. So the configuration, so I showed you the input-output, the resistor configuration, and then alternate functions are usually when you want to, for example, use SPI, then you have to configure the GPIO of that pin with some specific alternate function. What's up?
Are you going to put those links in the description?
What?
Like you say like more info like that.
Yeah.
Like if there's something useful.
So I'm going to basically. Oh wait, what does this more info go to? Oh, this goes to a application note by SD. But yeah, I'm gonna upload these keynote presentations so you guys can see them. You can have them whenever you want. So if we want to configure GPIO as output, so I think this is the demo. So in this demo, we'll blink a bunch of lights. So a bunch of LEDs. This actually has to be LEDs. And then the source code for it is basically the blinking LEDs. So let's jump back to the actual project, blinking LEDs. So in the last video, I ran this on the controller board, but let's just walk through the code. So there's like a whole bunch of includes that if you want to like use the GPIO library, just do include GPIO.h. So in this tutorial, in this demo, because we're using, we want to blink the GPIO lights. We want to blink them. We need to use timers. So I'm bringing the soft timer library and then the interrupt library because our timers use interrupt. And then there are various helper functions and macros that we're probably using here. And I don't know, I have actually never used this library before. Okay, so as you can see, interrupt init, soft timer init, and GPIO init, and this order is important. How do you figure out this order? Basically just jump to the interrupt.h, right? And over here at the top, it says if there's any other thing that needs to be initialized before this needs to be initialized. So interrupts don't need to be they don't have any dependencies. But if, for example, go to soft timers, so soft timer.h, it says requires interrupts to be initialized. So when you read this on top of, like, let's say you want to use a library, just always go at the top of that library and take a look at what that library is including, and then go to that library, so interrupts, and then include. So be sure to, like, for example, include interrupt and then call that, right? So back to blinking LEDs. Over here, we have the GPIO address for all the pins on the controller board. So you can actually, like, you've probably seen these in the schematic of the controller board. Usually not every single, like the silk screen doesn't contain all the addresses, so you would have to actually refer to the schematic. So you can actually, no, wait, let me walk through the rest of this and then you can record me. So, so this is the settings. So in this case, we want to flip the LEDs. So direction must be out. The default state, we just set it to high. So when you program the board, the LEDs should be just high. And then the alternate function, we just put as none because we don't actually use any peripherals here. We are we're not using I2C, UARTs, CAN, any of those. So we're just using the pin in of itself. And then the resistor, we just put GPIO res none. And then that's how you basically have to initialize the pins. So first you call GPIO init, and then init pin, and then I'm looping through this for loop, and I'm just toggling the states, and I'm passing the LED addresses that are defined up here, right? And I'm doing like a 50 milliseconds delay. So that's pretty much the code for it. So I've already run this, but you can just start filming it again. All right, so just zoom in on the controller board. Thank you, but controller board is more important. So as you can see over here, you can see the PB5, PB4, PB3, PA15, which are the same addresses that I had in the code. And then, oh yeah, so let's just start running this. Oh, whoops. All right, no, you don't have to get that. So every time that I program this, you can see that the board goes off for a second, and then it starts running it again. So because in this case it was previously running the same code, the behavior is the same. As you can see, there's like that last LED that's supposed to be like the blue LED has come off. So if you see a controller board where like the LEDs don't turn on, actually check the actual hardware to see if the LED is there. So that's another thing to keep in mind. Oh, you can stop. So GPIO as input, resistor configuration and demo. So resistor configuration. So this is what I just took this figure from the STM's data sheet itself. So in this picture, I'm kind of like zooming in. So when you're outputting the GPIO, there's so this is the I/O pin that actually goes out of your board. So this diagram shows what's inside your microcontroller, right? So in the case that you're outputting, this is your output data register. So when you write a 1 to this basically goes to here, and then from there it goes to here, right? So usually at your output, you want to, let's say you want to, for example, um, see, read the state of a switch, right? So by default, let's say that switch is connecting this to VDD, right? So if you so basically the resistor configuration is there for the output pin's default behavior. So if this is not connected to anything, or if it's connected to another component such that that component has a high impedance, so that's as if you have connected nothing to this line, right? So what would be the voltage of this line if it's not connected to anything? Well, you wouldn't know because you don't know, because like this is an output pin, right? So there's nothing inside this circuit that would pull it high or low. And let's assume that these diodes don't do anything. This is just electrostatic discharge protection. So if you, for example, have like some static discharge, like you just touch the pins, that basically protects that part. So if you don't disconnect these resistors, this line actually means that these resistors are controllable. So you can either connect them or disconnect them. So if you have no resistors connected, the state of this line is unknown. However, so by default, sometimes you want to set the state of these like resistors to pull the line down or pull the line up when it's not getting used on the other side. So that's usually good practice. And there are cases where that actually makes a difference. And we will see that once we take a look at the tutorial board where you want to, for example, read from the GPIO pins on the switches. It actually matters which one you configure. What's up?
So this is an I/O pin, and we can only connect one thing, right? Does it mean that we can't input and output at the same time? We can only do one.
Yeah, you can only do one at a time. So when you set the resistor direction to, the output resistor to be pull up, this resistor gets connected. So when no one is using this line, this resistor will pull the voltage of this line up to VDD, which is the high voltage in your circuit, which is 3.3 volts. And if you do it as a pull down, that way it will pull the voltage down to 0. So when no one is using this, or if it's connected to a device that is not driving this pin, then the voltage of here will be 0, right? And there's also, you can also choose not to connect either one of them, so like any one of them. So in that case, this will be floating, so you don't really know what the output, like the state of this line is, unless it's being driven on the other side by something else. And yeah, that's it. But you cannot connect both of these resistors together because that would result in a unknown behavior, and that's just there's no point into like connecting these two resistors together. So I'm going to show you this example GPIO output project because it's actually pretty cool. You can actually see the difference that these output state makes. So let's take a look at what the code looks like. GPIO output, GPIO output, example, GPIO, oh, I changed it to input, which is wrong. Okay, anyways, so over here, all I'm doing in this program is that I'm initializing a pin, and then I get the state of it, right? If this pin is not connected to any, sorry? What's up?
I just wasn't.
Oh, okay. So if I don't connect this pin to anything, what happens is that this pin internally gets pulled up by a resistor, right? So if this pin is not connected to anything, and I try and read the GPIO state, would it be high or low? High, right? Because let's go back to this diagram. So this is configured as pull up, right? So in this case, GPIO resistor pull up, right? So if nothing is connected here, this line's voltage will get pulled up by this resistor to VDD, right? So it will be at that voltage. So if I try programming this you can actually see what happens here. So I'm just gonna, in one terminal, I'm going to take a look at the UART logs. So got that. Okay, minicom-d dev, and over here you have this. So this basically listens on the UART lines of this controller board. And then now I'm going to try and program this. So what was this project called? Sample GPIO input. All right. So you can see that the state is high, right? Because it was pulled high. This was a pull-up resistor, right? So even if your pin is not connected to any peripherals, you can read the state of it, which is pretty cool, right? So now I'm just gonna do pull down. So now you expect the state to be low, right? Is that right?
Yes.
Okay. So I'm just gonna program this again. Builds the project. You can see that the state is low, right? There's also, sorry. There's also the resistor none. In this case, neither of those resistors would be connected, right? So what do you expect the value of the line to be? Well, we can't tell. We don't have any means of like knowing what's happening inside the circuit, right? But let's just do it for just experimenting. So you can see that this is low. When I was preparing for this tutorial, I ran the same thing, and the state was actually high. So it's an undeterministic behavior. So you wouldn't really know.
Is it based on the previous one?
It could be. It could be the case that it kind of like preserves its previous value. If it's being driven by a register, that totally makes sense. So that's pretty much the GPIO resistor setup. And then, yeah, so that's our GPIO tutorial. Aw, thank you guys.